All right, guys, welcome to chapter 3 for your scripting class. Today, we're going to be talking about a little bit of programming with all our Arduinos. So, what we're trying to do here is we're trying to understand some of the basics of programming. So, that way, when we start getting into Bash and Python and PowerShell, that all of these basic syntax things that we're learning about today are going to transfer between our Arduino to everything else we go throughout this class. Okay. So the first thing I want to do is, well, why are we learning to program? And so we've already seen basic wire circuits, we've done stuff like that. But now we need to tell the Arduino what to do and when to do it. And so this is where programming comes involved. It's going to be the brains of the operation. So this chapter here will dive into the Arduino development, and we'll learn how the programming language that is how we're going to structure our instructions. Arduino IDE is where we're going to run with this. So IDE is the primary tool that we're going to use for this first couple labs. Now, we've already used IDE in chapter 1 and in chapter 2, but we're going to continue using it in chapter 3. Remember, this is our all-in-one application to allow us to communicate with our Arduinos as well as program instructions to it. Now, in previous classes, we've used pre-built programming instructions. We're going to start looking at what those instructions are and how to dig into them. So the first thing is we've had this question on our quiz before. When you're editing a program inside of Arduino IDE, what is it called? And we like to call it a sketch. A sketch is what Arduino IDE calls it, okay? And the reason why we like to use an IDE versus a notepad or some other application is it's going to give us features like syntax highlighting. In other words, it's going to tell us where things are right, where things are wrong, and help us decipher our code in different colors. So it's a lot easier to read. Also with brackets, it will help us put the open and close brackets together. And you'll see that as we go through this. So one of the key features is going to be syntax highlighting. Now there are going to be a couple different icons at the top of IDE. We've already used the upload button in the past. It's the arrow to the right. But there are a couple others as well. One of the buttons that we want to look for is verify and compile. Basically, do we have any typos in our code before we upload it to our Arduino? By verifying and compile the code before we upload it, it saves us a little bit of time. We're not going to override the code on the Arduino board unless it has been verified. Now, you could just skip straight to the upload button, and even if you haven't compiled it before, it will then verify and compile and then also upload to your connected board. This is assuming that you have your settings set up correctly. Remember, you're going to have to pick your board and your COM port when you first plug it in, just like we did in chapter 1 and 2. Now, how do we communicate with our Arduino? We're going to communicate through the serial monitor. The serial monitor is a really great tool for us to see what's coming in and out of our board itself. It is a separate window, normally at the bottom of the screen, and you can even pop it out into another monitor if you feel like it. It's where all that two-way text communication happens. Now, we can also print things from our board to the screen of our serial monitor for debugging and for other uses down the line, which we will be using when we deal with sensors. Now, before we get into programming itself, we do need to understand the structure of the sketch. Arduino is a little bit different than some of the other places, and there is a basic structure that we need to come through with. The first part of that structure is going to be the setup function. So when we first open up a brand new sketch in Arduino IDE, we'll notice we have two functions. One is setup and one is loop. The first one, setup, allows us to put anything inside of it, and it will only run once the board powers up. After it runs once, it will never run the stuff in setup ever again. Now, if we unplug the power to our board and plug it back in, it will then boot up, look what's in setup, run it, and then go to loop. But remember, setup is just anything that we want to do to set up our program. Anything that's going to be a one-time configuration or setup. What's going to go in here? Well, one of them might be your pin mode. Do we want an input or an output device? This is where we would put pin mode. If we want to start talking in that serial communication, so we can start talking in serial monitor, we may want to start the communication through serial. And then any other libraries that we might be using. Now, libraries are there to help extend our code. And what that means is if there's something that we want to utilize that needs a driver or some other set of instructions, then we would use it in the setup phase. This will allow us to use things like screens or other sensors that might need some special programming. Our second section of our sketch is going to be the loop. The loop is what's going to run over and over and over, continuously, repeatedly, forever, until the Arduino is powered down. So it could be checking a sensor or turning on or off an LED, whatever it may be, we're going to use the loop cycle. Now, if we refer to Chapter 2 Lab, we will notice that in the setup cycle, we were putting in the pin layout, such as the output pin layout for the LED, while in the loop cycle is where we tell it to turn to high. We told it to delay for 1,000, and then we turned it to low, and we delayed for 1,000. And this is what allowed it to look like it was blinking, because we would turn it on, we would turn it off, and then when it would loop around again, it would turn on and off. And so it just looked like it was blinking to us over and over and over. So what's going to go in the loop? Well, this is going to be input from like our sensors. Any of the sensors that we're going to attach to our circuits are going to be here. We've already done an LED. This could be motors. This could be sending data or status updates. Maybe we want to print to the screen the temperature from the temperature sensor. Whatever we're going to do, we're going to stick in the loop function. Now, there are going to be some things that we may want to bring in temporarily, and this is what we're going to call a variable. A variable is a name container on the Arduino memory where we can give it a piece of data. For instance, if I owned a car wash, what I could do is the model and type of car can be in type of a variable called car. And anytime I wanted to know what my current car that I was washing is, I could just look at the variable car. So think of this as a temporary storage location where you can store something while you're processing it, so you know how to call upon it at a later time. Another analogy would be maybe you were processing data for a certain student. We might have first name, we might have last name, we might have birthday, we might have the classes that they're attending. All this information would be great if we can store it as a variable. For instance, I could have first name as a variable, and in that variable, I can put the first name of the student, maybe Sally. Now, as we go through there are different ways of declaring a variable. So we need to tell it a data type, and then what variable name we want to give it. For instance, if we want to only blink 8 times, we could actually create an integer called blink counter, and then in that variable, we can put a number. So we'll talk a little bit more about the different numerical types again. Remember, integers are going to be things we can do arithmetic on, anything with math, and these are whole numbers only. Just like if we were talking about a pin of the board, the LED pin of the board is always going to be a whole number, so we would probably put it as an integer. This way we know that this is a whole number, and we know what we can and cannot do with it. So, what are those common data types? Well, the first one is integers. This could be any type of number that is whole. Negative 100 is a whole number. 0 is a whole number. 13 is a whole number. Now, if you want to do something with decimal points, that's when we're going to use floats. Floats are going to be any number that just has a decimal. Doesn't mean that it can't be a whole number. It just will always have a decimal point with it. So if I had 0 as a whole number, we would look at 0.0 because it has to have a decimal. Now there isn't a limit on how many decimal points you have with a float. It just means that there is a decimal in it. So anytime you want to use numbers that are not whole, we would use float. If we want to store variables of two values, booleans, we would use true or false inside of a boolean. I like to look at this as a 0 or a 1, on or off. Booleans are a great thing to utilize within coding to test if a value is true or false. For instance, maybe I only want to do something if the age of the student is above 21. So if the age is greater than or equal to 21, then I can sell them alcohol. If they're younger than 21, maybe I can't. So I could have a test that is a Boolean to say, is age 21 or greater? If it's true, I'll do some side of logic. If it's false, maybe I do something else. Okay? There's another one called character, and this is going to be for storing single characters only. Char is literally one character. It could be an A, a B, a C, just one. If I have multiple characters, that's when I will have a string. Now, there are going to be times where we want our variables to be there, but we don't want them to change. For instance, in our setup phase, we may want to say our LED pin is going to be 8, and we don't want it to change anywhere in our code, so we can initialize it with the constant variable. So a constant is just anything that's going to be assigned at a one time, and it can't change, okay? Think of it like a variable that's just locked in time. You cannot change it. Variables can be changed at any time. Constants cannot. Once they're initialized, they cannot be changed. There are going to be times that we're going to do different actions to different data sets within our code. First one, we might do some math. We might have a sum. We might subtract. We might multiply. We might divide. We might mod it. And for those who don't know what mod is something that's a little bit new for a lot of people who have never done programming in the past. Now, most of us know what addition, subtraction, multiplication, division is, but mod is something new. And it's pretty easy to actually know that one. So if I have 3 people and I divide it by 2, what is the final answer? Well, most people would tell me it would be 1.5. Why? Because 1.5, 2 goes into 3 1.5 times. But mod is only caring about the remainder of division. So if I take 3 divided by 2, it goes in at 1 time. What's the remainder? Well, I have 1 as a remainder. So the mod of this answer would be 1. And the same answer would be for anything that you divide. It will let you know just the remainder of any division problem. So if I want to say 10 divided by 2, that would be 5 evenly with nothing remainder. Mod would equal 0. But if I said 11 divided by 2, well, 2 goes into it 5 times, and there would be 1 remainder. So mod would be a 1. Okay? Now, it depends on what you're doing to solve a problem. You may need mod to solve a problem to figure out, hey, I've got 10 apples. I've got 20 students. How many apples can each student have? This is basically what we're talking about here with mod. Can we break things evenly? If not, is there a remainder? Now, assignment can be something a little bit different. We use assignment when we're dealing with variables. So if I want to put your name into first name, I would then say first name equals Sally. If I wanted to use concatenation, I can do mathematics with assignment. So I can say plus equal 1. So if I say an integer value plus equal 2, it will take the current value of the integer, add 2 to it, and store it again. And the same goes for subtraction. And we'll go through a few of those examples later, but just know these are all assignment variables. And so anytime we're dealing with constants or variables, this is what we're going to be utilizing. Now, there are going to be times where we want to compare two things. For instance, is the first name equal to Sally? I may say F name equal Sally. And this will come with a true or false. Everything with a comparison will come out with true or false. For instance, is that first name Sally? If it was true, then yes, the first name was Sally. But what if it was Michelle? Well, then that would be false. So that's how we compare things. Now, there are different ones here. The first one here is, does it equal? The second one is, does it not equal? The third one here is, it less than? The next one, is it greater than? Is it less than or equal to? Or is it greater than and equal to? Okay? So all of these are going to come out with a true or a false. Is it true or is it false? Last thing we have is logical. Logical is the and or not. Okay? Now, we already dealt with a little bit of a not here, because not equal, exclamation point equal. But we could also just put a not in front of something. For instance, if the student age is not equal to 21, maybe it could be 22 or 20 or anything in between. Just not something. Maybe I'll do something special. Logical could be an and or an or as well. For instance, let's go back to my liquor analogy here. Is the person 21 or older? True. Does that person also have a valid ID? True. Then I can sell them liquor. But if for some reason the person is not 21 but has a ID, then I would say one of these is false, which means I can't sell them liquor. Versus or, one or the other can be true, and I can do something. Okay? And we'll look at those further as we go through code. Now, I do have to make sure that you understand that there's a very critical distinction between equal and double equal. Okay? Remember, single equal is an assignment operator. It puts a value into a variable. Okay? If I want to test something, a comparison operator, I need two. Now, this is something that a lot of people will mess up as a new coder out there, as a new programmer, is you'll need to make sure that you're using double quotes or double equal signs when you're trying to compare values between two things. All right, so we learned a little bit about the setup phase and the loop phase of Arduino. We learned about what a variable is, a constant. We learned about how to do a little bit of arithmetic. Now, we're going to go further into controlling the flow. Now, I don't expect you to be complete experts after this chapter. This is just an introduction. And as you go through and see this a little bit more as you go through this class, you'll start becoming familiar with the information, okay? Now, based on certain conditions is how we will do certain things with our code. And this is how we're going to bring in flow and intelligence in our code, okay? The first one we're going to talk about is the if statement. The if statement allows the program to execute a code only if a condition is true. Remember when we were talking about Booleans, about true or false? Only trues will actually execute this code. Now, we can extend it to have multiple tests by using else if, or we can even have a final thing of else to make sure that we're covering all of our bases. And here's an example, for example. So in today's lab, we're going to be dealing with a button and an LED. If the button state equals high, then that means you press the button. Maybe I want to turn on the LED. But if it's not set to high, that means it's low, that means the button's not pressed, then I want to make sure that the LED is turned off. Okay? So every time this program loops, it's going to test. Hey, what's the state of the button? Did someone press it? If so, it will turn the LED on. If not, it will just make sure the LED is off. If it's already off, we're just going to make sure it's off, okay? So every time it loops, it's going to come test this and make sure, hey, is this on or is it off? Now, if we want to go a step further, repetition, we can use the for loop. The for loop is really great for when we want to count or go through something an X amount of times. For example, we want to blink an LED 5 times. So we can use a counter variable to keep track of every time we go around. And once we hit it 5, then we end the loop. The for loop is a really great thing to utilize if you have a set number of iterations you want to go through. On the other hand, we have the while loop. The while loop will continue as long as a given condition remains true. So it will test every time it goes around for a certain feature. For example, if it says go around every time the sensor is below 100, but at the moment the sensor is above 100, maybe then the value is false and it will break the loop. This is really good for when you want something to continue to happen until a value is not there anymore. And a really good analogy for this that you'll see in real life is you're going to see that your thermostat, this is how it works. We set the thermostat to a variable. We call it temperature. I want the house to be 72 degrees Fahrenheit. Okay. Well, in the summertime, if the temperature gets to 73 degrees Fahrenheit, then a condition will be set to true, and it will say turn on the air conditioning or turn on a fan. The moment the temperature drops below our set variable of 72, it will then break the loop and turn off the fan. Now the fan will turn right back on as soon as that condition remains true. So in code, we could easily say while temperature is equal or greater than 72. Okay, that's when I want to turn on the air conditioner. If it's less than 72, then the condition would be false, and it will not turn on the air conditioner. Okay? Now, if we want to talk to the different pins on our Arduino, remember that there's a ton of pins on our Arduino. This allows us to control a lot of different devices. The Arduinos will interact with all of our components, but we have 3 fundamental functions to control them. All right? So we talked about pin mode. Pin mode is either input or output. What type of device are we dealing with? Are we taking the technology from in the real world and bringing it into the digital world? If so, it's an input. Or are we taking the digital world and bringing it to the outside world? That's an output. Okay? So pin mode would be the first way that we would interact with a pin. The other thing is, well, do we want to read from that pin? What is the current value? For instance, if this is an input pin, I would definitely want to read on it to see what is the temperature? What is the current status of my sensor? Or maybe it will be a digital write because this is an output pin, such as an LED. We might do digital write, high or low, depending if we want it on or off. So remember when we were talking about pin mode, we have outputs and inputs. So it all depends on what we're connecting up to it. An LED is an output, but a button is an input. Now, depending on the different types of inputs, there is a pull-up method. And you're going to see this in today's lab, okay? We may want to say the pin mode is a pin 8, and it's an input, but it might be a pull-up. So basically what this means is the pin will read as high, even if we don't push anything. So if we don't do a pull up, then it's going to think that off is low. But for some reason, there are going to be times where a button will be high by default, and maybe by pressing that button, it will turn off the electricity to the button, which then makes it low. So as a pull up, we need to make sure that we can tell it that. And you'll see this in today's lab, okay? And so this is one of those that's pretty hard to describe And the way that I like to tell people is if you're dealing with a pull-up circuit, if you did a digital read and you're not even pressing the button, you'll see high by default, okay? And if that's the case, we do need to tell it that it's a pull-up input. If it's low by default, then we don't need to include pull-up here, okay? We can just take that off. Now, digital write, we've already dealt with this before by doing an LED, by turning it on or off. Remember, high being on, low being off. And then digital read could be the same thing. Remember, if we're doing an input or a pull-up, it's either going to be high or low. And depending on what we see, it's depending on what we're going to do in our code. So in today's lab, to practice a little bit of this, you're going to basically take lab 2.1, which is our blinking LED program. But instead of it being a blinking LED, what we're going to do is add a button to our circuit. The button then will control whether or not the LED is on or off. So we'll have two pins, an input pin and an output pin. The output pin is for the LED. The input pin will be for the button. By doing that, we can then read the status of the button and control the other pin. For instance, if the button is pressed, we're going to want to turn the LED to high. If the button's not pressed, then we want to take the LED and turn it to low. Now be aware, if you do get this backwards, if you don't press the button, the LED will be on. And if you do press the button, the LED will be off. That's when you're going to deal up with the pull-up method. Okay? So if you only did it as an input and you had it backwards, the LED will be backwards from what you think it should be. Now I'll let you guys go through that and actually do that as a class. Make sure that you are going through it with the book and understand how some of these work, okay? And then if you feel really adventurous, maybe add another LED in. Maybe have that LED turn on when the button isn't pressed and off when it is pressed, but have a secondary LED that turns on if the button is pressed. Have some fun with this and try to learn some of that basics. So today we talked about variables. We made decisions with if else. We talked about loops with the for and the while statement. We are now even controlling hardware with our I/O functions. Now the I/O functions are all digital. We haven't talked about getting into the analog world completely. Chapter 2 we touched about it, but in the future we will be dealing with more sensors, which are a lot of analog capabilities. Now, as you go through this, just make sure that you're understanding why things are doing what they do, okay? Follow it closely, take your time, and when things don't work out for you, because welcome to programming, there are going to be a lot of times where it's not, remember your troubleshooting methodology. What worked, what didn't, and work your way through the problem, okay? I'll see you for Chapter 4.